Hello, my name is Alexandra Jones. I'm the editor of The Ophthalmologist, and I'm very pleased to be moderating today's discussion, Myopia Roundtable. I have great experts on this topic with me. We have Professor Andrzej Grzybowski from Poland. We have Dr. Sarah McCullough from the University of Ulster in Northern Ireland. And we have Sean Yanchula from the United States. And now, to start with, could I ask each of you to tell me a few words about yourself, your background, and what you are working on currently? Dr. McCullough, could I start with you?
Certainly, Alexandra, thank you. My background, I'm a lecturer in optometry and vision science at Ulster University in Northern Ireland. And I suppose for myopia, I come to this roundtable really from an epidemiology background. We've been looking at the epidemiology of refractive errors in children living in the UK for a large number of years now. So from around about 2006, we've been looking at how children's eyes change and grow with a large sample of children from Northern Ireland. I'm also working currently on a clinical trial for using some of the myopia management spectacles from Hoya. So from a few different angles in terms of myopia.
Thank you. And Professor Grzybowski, and I'm lucky enough to be able to pronounce your name right. We come from the same country.
Yes, thank you. So I am ophthalmologist. I am professor of ophthalmology at the University of Vermont, Missouri, where I'm also a chair of the department. I'm a founder of the Foundation for Ophthalmology Development, which is involved in some educational programs in myopia. I also run a pediatric ophthalmology clinic for about 20 years, so it's my very practical experience to deal with myopia. And I have been involved in different aspects of myopia research in recent years, epidemiology or treatment studies. I've been a member of the task force for myopia control by American Academy of Ophthalmology that prepared American Academy of Ophthalmology recommendations 2020, and last year in Europe, we as a group organized by European Society of Ophthalmology prepared our local recommendation published last year, I think in April, in European Journal of Ophthalmology. In short.
Yeah, a lot of myopia experience there. And Sean, we have actually met in person. You're talking to us from the States, so it's morning for you. Tell us, you've been involved in many projects, many of them to do with myopia. Tell us a bit about your background.
Thank you, Alexandra, and good morning from New York City. It is still good morning here. I think we're waiting for a cyclone to hit us in a few hours, so I'm glad we're actually getting this done early in the morning. Yes, you're right. I'm a professor of ophthalmology at the New York Eye and Ear Infirmary of Mount Sinai. And I have spent a lot of my time in research and development of projects across the spectrum, from retina with Lucentis all the way to microinterventional technology for glaucoma, cataract surgery, and so forth. And I'm particularly pleased to be here and be talking on that forum about progressive myopia, because it reminds me very much of the days when we were developing the first anti-VEGFs in ophthalmology with Lucentis, where we changed the paradigm and treatment of macular degeneration and diabetic macular edema. So it kind of replays for me, and I feel we're at the same tipping point for progressive myopia, where it can really impact something very important, not only for us, but for our children too. So thank you for inviting me.
Yes, children are definitely featuring heavily in the discussion about myopia. So first of all, I wanted to ask about incidence of myopia. How common is it, and how this has changed over the past few decades? Andrzej, can I come to you first?
Well, we know that the prevalence of myopia increased significantly in the recent years, in the recent decades. However, not to the same extent in different parts of the world. So we are quite aware that what happened in Asia, and as a matter of fact, a lot of data we deal with, a lot of publications, informations, and comes from Asia regarding myopia. Not every part of the world is so well, let's say, represented in this research. For example, we do have much less work from South America, for example, from Africa, and many also European countries. Also, we do have some epidemiological studies in Europe, but not regarding every country. But based on what we do have, also in Europe, we are quite aware that the prevalence of myopia increased in the recent years, not with such a dynamic like in Asia. As we know, in Asia, in some age groups, it is up to 80%. In Europe, it is probably between 40–50%, depending on the age group. But of course, it brings a lot of concern to us, because we can learn from what happened in some other parts of the world. Probably the similar issue is to US, but well, I hope that my colleagues can supplement my what I was saying. Yeah.
Sarah, what can you tell us about the data and what you see?
So some of a lot of the work that we've done has been around the prevalence and the increase in the prevalence in the UK. We've looked at how the prevalence has changed in our contemporary children who were recruited from around 2000, early 2000s, and we compared that with children who were tested in the 1950s in the UK. And very similar type of population, but just a difference in time. And we find that the prevalence had actually increased by twofold. So it had doubled in the last sort of 50–60 years. At the minute, the prevalence would be about 1 in 5 children in the UK would have myopia. But obviously that continues to increase, and whenever you take into into adulthood, where you have some adult onset of myopia as well. But yeah, one of the other interesting things that we found was that actually children were becoming myopic at a younger age. So we previously would have thought children were becoming myopic more so in the teenage years, but actually the comparison again with that older cohort, the one that was 50 years ago, it actually showed us that instead of becoming myopic in teenage years, it's actually in the primary school years, or sort of that earlier age group from about 6 years of age. And that's a worrying thing, as well as the increasing prevalence. Because if you become myopic at a younger age, then you've actually got much more scope to become more myopic, because it does increase as if you've got a longer period of time of the development of myopia, you can have then a much higher resultant endpoint in magnitude of myopia, which is also really worrying, as well as the increase in prevalence.
Sean, could you add anything to that?
Yeah, I think we can probably spend the better part of the day talking about myopia prevalence, because I just think it's one of the most fascinating diseases now that we're facing. And somebody who has done public health when I was at the Harvard School of Public Health, it really became apparent to me, kind of took me back to my MPH days, and just looking at how fascinating myopia is. And I'm just so happy that we're turning our attention to this. For me, some of the statistics that are most impactful is when we look back, for example, in Asia, 50 years ago, the prevalence was about 10 to 20% from what I understand. And we're talking now prevalence of 80 to 90%, particularly in East Asia. So for me, for 50 years, to have such a dramatic shift in the prevalence of a disease of epidemic proportions is really telling. In the US, I think we're probably in around 34 million people today have myopia. I think the projections call in the next 20 to 30 years will be probably at 40–45 million people. So it's something that's really growing, and it impacts us. I see patients who are myopic, and they ask me, about their kids, because we know some of the risk factors are about that as well. And what concerns me is, and even being now in the process of running a phase 3 program through Inovia, what concerns me is that over the last couple of years, we may see an inflection in the epidemiology, and the curve may become even steeper, because two of the factors, I mean, that are most impactful is really how much time kids spend outdoors, and also how much time kids spend on their devices. And both of those are really impacted negatively by the pandemic. So I always say there is an epidemic behind the pandemic, and I think this is something that we'll probably see the consequences later. So the other thing that's important is that myopia prevalence increases with age. So maybe it will start about 10% or so when kids are below 5, but sometimes when they go to 18 in the US, I think, especially in Caucasian kids, we're talking about maybe prevalence of 20% or more. In the Asian population, upwards of 80%. So this period between 5 and 18 is really something for us to try to impact and understand. And the beautiful part here about epidemiology is that epidemiology is driving our understanding of the disease.
Yeah, I would like to add something just to support what Shen just said, that there are a few quite convincing studies published recently showing that during the COVID epidemic, the progression rate of myopia increased. Of course, they mostly come from Asia again. However, well, there was a study published in JAMA Ophthalmology, as I remember. I also, with a group of Chinese colleagues from Beijing, we just published another study also on the same topic. So we collect more and more evidence for that it has been even worse with the COVID epidemic.
Just to add to that, I think as well, anecdotally, we've had a lot of comments from optometrists in our area in the UK. There's no evidence necessarily published to say that the progression of myopia had increased over the pandemic, but definitely anecdotally, we're getting a lot of reports of that, and even parents coming to us in our clinics are saying that, you know, they can see that their children's eyes have changed and progressed in that time, and that most likely due to those environmental changes. So I think it's something we really need to consider in terms of what sort of advice we need to give to parents in terms of what sort of lifestyle changes we can try to do to help children.
Absolutely, and unfortunately, some of the factors during the pandemic, like virtual learning, were unavoidable. I saw some research presented at the most recent AAO by Will's Eye researchers and clinicians, and they looked into the impact of virtual learning and virtual schools during lockdowns on children's eyes. So what are the reasons for this increase? You've mentioned genetic factors, Sean, you talked about that. You've obviously mentioned screens and less time spent outdoors. Is the mechanism well researched? Andre, could you tell me more about this?
Well, we still learn. I mean, we don't know everything. However, this area of unknown is getting smaller and smaller for us. So finally, as we understand it now, less time outdoors, more time spent on near vision activity. It's not only reading, of course. It's just this time spent on any device from near distance, especially in young children. This is particularly very dangerous to give a child mobile phone on a tablet when he or she is 2 or 3 years old, or even before the age of 6 or something like that. So we should be very, we should make parents much more aware about that, about the risks of such a behavior. Of course, well, we don't know much about the genetic background. The genetic story is around for a long time. As a matter of fact, in the second half of the 20th century, we generally believe that this is mostly genetically driven myopia. Now we know that the environmental influences are very strong, probably even more important now than the genetic background. Even the major argument for the genetic background, parental myopia, we well know that the risk for a child to become myopic with a one myopic parent is higher than the general population, and with the two myopic parents is much more higher. However, even this is not really, it might not be only the genetic factor, because we know that parents, they share some behaviors to children, and it was shown in many studies that, for example, the children of parents who read more, they read more, and so on. So it is sometimes quite complicated to know everything. Well, in short, I will let some other colleagues to supplement. Yeah.
Sean, what can you tell us about the factors behind myopia?
I think that, I mean, I do have quite a few patients, and I see the parents, or if and the kids come, I usually see the adults. I'm not in the pediatric side. So I look the other way, usually from the parents when they come with their kids. And if I have myopic parents, I actually look, when I look at the kids, I see they're wearing glasses and they're myopic. And so I think, as mentioned previously, it's very well established. If you have one myopic parent, I think the risk is about 50% higher. If you have two, it goes 2 to 3 times. So definitely some indication there. Some of the twin studies also have shown that there is a probably 70+% effect of genetic effect there. Now the trick is, all that is great, and I think it shows an effect of genetic component there. The trick is which one it is and how to identify the genes, and there have been tens, if not hundreds, of genes potentially implicated. And again, genetic studies and further studies of that would be very helpful. I think right now, when we're going into that field, similar to what's happening in other fields, especially as we come with a therapeutic paradigm and open up the therapeutic field with entry of industry and academia and putting more attention to that, I think we're going to learn tremendously, and we may identify some genetic components, which will be very timely, because we do know that the next decade or two will be where gene therapy is coming of age. So hopefully, if we identify some genetic components that can be modulated, that will be very helpful therapeutically. But I do believe that there is a strong genetic component. Of course, something that environment continues to play a role on.
Yes, we'll come to the innovations and your wish lists a bit later in the discussion. Sarah, could you add anything to the topic of factors behind myopia?
Sorry, just before on that topic on the genetics as well, I think the genetics is a really important factor, but in some ways what we find is that the change in the prevalence has actually happened too fast over the course of the time period to actually just be genetics alone, and that's why we now recognize that the environment has such a strong effect. And almost it could be that someone might be genetically predisposed, but their environmental influences might be up-regulating whatever genetic aspect is there as well. And also we see in our clinics as well that there are lots of children coming now who have no myopic parents. So it really sort of does demonstrate that there is definitely some sort of environmental influence, and it definitely seems to be that outdoor activity time that seems to be the key one. We always get sort of hung up, and parents really love to get hung up in terms of the screen time. But sometimes actually, or in some reports there, in particular the Sydney Myopia study in Australia has shown actually that if you can actually get the children to spend more time outside, even if they have to do that near work activity because we can't really say very much about, we can't get them away from that if they have to do that for their schooling, is that actually if you can get them out for a good period of time, we recommend about 80 minutes per day in daylight hours. So the actual level of light is actually important as well. But if we can do that, we can almost offset that sort of negative effects of doing that near work as well. So the outdoor activity does seem to be one of the key things that seems to have changed, and that really does sort of correspond with the changes that have happened in children's lives over the past 50 years to demonstrate the difference between the prevalence as well.
Yeah, let me add something. I mean, against the simple genetic, let's say, influence, because I remember there was a study conducted on one of Asian minorities in Australia. I mean, the authors wanted to check the progression rate. If I remember well, it was a Korean ethnicity and living in Australia. If the progression rate would be similar to that in Korea or in Australia. And the result was that it followed the Australian environmental, let's say, standard or rate. I agree that some genetic background is important. However, probably compared to environmental factors, it's of minor importance in my opinion today.
And Sarah, you mentioned before about the dangers of myopia occurring later, earlier in childhood rather than later, as in previous years and decades. Could you tell me why that's dangerous?
So if a child becomes myopic at a younger age, first of all, we know that children's eyes grow. All children's eyes grow as they get older, but we know that children's eyes tend to grow more whenever they're younger. So they have naturally a much greater growth in that younger period of time. If the child becomes myopic at the time that they are growing more, then they have more time for development of that excessive eye growth, which causes the myopia. So if we can actually delay the onset of myopia to a time where the eye has slowed down its growth, so sort of more into the teenage years, well, then actually we can prevent them becoming such a high myope. So the worrying thing is that if children become myopic at a younger age, they have more scope for higher magnitudes of myopia. So some of our work's shown that if a child became myopic before the age of 6, they're likely to end up around about -5, -6 level of myopia. Whereas if we can push that back to becoming myopic at the age of 10, they end up around about -2, -3. So there's a huge difference even just by delaying that onset of myopia. And some of the work by Mark Bullimore and his colleagues have shown that actually by, for every diopter increase of myopia, that you've got a significant increase in the risk of having some sort of visual impairment or myopic maculopathy later in life. So if we can even, push back the onset of myopia, even by suggesting some environmental factors that they can change in their lifestyle, that can make a really significant difference in terms of their overall sort of endpoint in terms of where they end up later in life.
Dawn, can you talk a bit more about these ocular disorders that myopia can influence in later life?
Yes, again, this can really cover the spectrum, and I think it's getting a lot more attention today because most people out there, when we talk about myopia, they think it's something very simple and correctable, and probably so if it's in the -2 or -3 range, or so, we can definitely address it with glasses, with LASIK. But I think what's coming to light more recently is that whole point that was mentioned earlier about visual impairment from myopia. And one of my patients, for example, is -18, and at 45 in both eyes, she had bilateral retinal detachments, and she has been blind ever since. So again, here is one very severe complication, and especially if we get into the very high myopia range, above 6, above 7, and in some cases 18 and beyond. Now we're talking some really, really significant impact on the vision, on the lifestyle. There are some really good studies about worldwide productivity that's lost from myopia. So things like retinal detachment is really much higher risk once you get into the higher ranges of myopia. Pathologic myopia associated with retinal atrophy, macular scarring, even choroidal neovascularization. These are things that we see in the offices all the time. And again, this is where if we have some sort of a therapeutic intervention to make a difference, and I think it's a big difference, somebody ending up -5 and -2, or somebody ending up instead of -10, -5. I mean, this is huge in terms of all the sequelae that we're talking that can have visual impairment, not to mention just the ability of that person to function normally and not to have a very big refractive error. So there's a lot of things that are coming to light as we dive into the epidemiology of that. And all of the things that can really impact the curve of that disease can make a big difference here.
Yeah, what do you see in the data and in your practice?
Yeah, I would like to add one thought. I mean, very often patients do not understand these risks, and they even believe that, for example, with a refractive surgery, they can manage the problem of myopia. To some extent, they can. However, they completely do not eliminate all of these risks related with the high myopia, what was just said. So this is another issue. I mean, because refractive surgery became very common in the recent years in some parts of the world, and enabling people to not to wear, especially glasses in myopia. However, people do not understand that the eye anatomy keeps the same as before refractive surgery, and all of these risks are the same. So there's a lot we need to do to educate people, to share this information.
What have you seen in terms of the risk for other ocular disorders in data and in your own practice? Sorry, Andre.
Sorry, I did not understand the question. Could you repeat it, please?
Yeah, sure. So still talking about the risk of other ocular disorders, what have you seen in the data? How does that risk increase with myopia?
Well, the data is clear. I mean, it was already mentioned by Shen. I mean, 12-fold increase in retinal detachment rate with high myopia, around over 5 times of cataract, 3 times more glaucoma, and even in the natural course, without any complications, 30–40% will have visual deterioration due to the macular problems. So yeah, I mean, the high myopia is a serious problem. I mean, we should also share this information. We do not really think when we speak about myopia about the low refractive errors. I mean, we do not care much if the child will be -2 or -3. What we really care is how to make the myopia as low as possible below high myopia. Of course, sometimes the child will get, but it's still better to have -6 than -10, or -7 than -15, for example. So every diopter or every millimeter of the axial length we can get less, it's good.
I would maybe just disagree a little bit with what you said there, just Andres, about the low myopes. I think we have to change our mindset a little bit, that actually no level of myopia is safe, and that for every diopter that we can save, we've done some good. I think it'd be about every diopter of increase in myopia increases your risk by about 30% for having some form of visual impairment. So I think we've always had it in our heads that high myopia has been a significant risk factor for all those different conditions, glaucoma, retinal detachments, etc. But I think we need to change our mindset a little bit to remember that actually, if we can even control any level of myopia to a lower degree, we should really help improve the sort of the significant visual impairment that will happen later in life across the population.
Yeah, I mean, I think I echo that fully, because when we look at epidemiologic studies and risk factors very often, and you go to diabetes literature and so forth, you look at, odds ratios of 1.5, odds ratios of 2, and people really get excited, or relative risk. When we look at even progressive myopia, or low level of progressive myopia versus high, and moderate in between. And it's very titratable in terms of all the risk factors. When it comes to things like myopic macular degeneration or retinal detachment, we're talking about odds ratios of, on the low end, for the lower side, of 6 to 7, to sometimes on the higher end to 300 or 500 in terms of some of the risk with very high level of progressive myopia. So again, these are really significant risk factors. Just want to be absolutely clear. This is different than the conversation that you have with your patient about how wine or alcohol affects your intraocular pressure. And you're talking about, things that are about 5% or some study that came out. We're talking very consistent studies, very high levels of relative risk, and very well established from that perspective, which is a great starting point to really focus on addressing that as an underlying root cause type of pathology.
Let's talk prevention. Education has been mentioned. How is that achieved in Northern Ireland and in the UK in general, Sarah?
So we've been trying to raise awareness to practitioners to make sure that they're trying to give try to predict the children who are most likely to become myopic. And some of the work that we've done has been able to identify some sort of predictive clinical metrics in terms of, as we discussed earlier, the parental history of myopia, but also what level of refractive error, or the level of sort of the need for glasses really at a young age can give you a good indication as to whether or not that child's likely to become myopic or not. And also we've been able to determine sort of what level of eye length as well, so the axial length, that is likely predictive of who again is likely to become myopic. And we've developed sort of like a risk indicator for use by practitioners to be able to use those different clinical features to determine which children are most likely to be myopic later in life. And really those are the children that we need to be given the most sort of advice in terms of modifying their lifestyle and their environment to be able to try to, if we can, push back that onset of myopia. And we've been trying to promote that, just particularly through practitioners, making sure that they're aware as to who is most at risk of future myopia, to try and see if we can get that sort of like healthy visual diet information over to them, getting that more time outdoors and less time spent in their work activities. But we've been doing that, as I said, with practitioners, but I think probably now what we need to do is more of a public health message as well, if that is possible. It hasn't really been promoted, suppose, in much detail in the UK at the minute, but I know in other countries, in China and Australia, they have little flyers that say, about getting, making sure that children are spending more time outdoors. So that's probably something that will happen in the future, I would imagine.
Andre, I know that you obviously educate parents who come with young patients into your practice, and you've also worked with teachers, is that right?
Yeah, but well, I can say that the area of unawareness is still very huge. I mean, they are both among, ophthalmologists. I mean, many, or if not majority, of ophthalmologists are still very much unaware about this problem in terms of epidemiology and the methods of treatment. And it's, of course, even worse with others, medical doctors like pediatricians or general practitioners. Of course, the problem is with teachers, because teachers, they play also a very important role in the system, because of course they can make the better environment for the children. Children spend a lot of time in schools, so during this time, of course, they can spend more time outdoors or not, depending awareness of the school system or teachers. Then parents allowing children for some dangerous behaviors, as I mentioned before, with the devices and so on. So yes, we do. My foundation conducts several social educational campaigns in Poland, in our region, with self-governments. We produced movies or short films for the TV, and we share the message to the schools and via schools to parents. So we believe that it's very important, yes, and it should be done.
Sean, what's your experience?
Yeah, so very interesting. As a physician, when I see patients, I never used to focus on myopia and have a conversation. And most of my patients are glaucoma patients. Having now spent the last 5 years thinking about myopia, particularly from therapeutic perspective, I just realized we're facing an enormous epidemic, and I spend a lot more time one-on-one. When I see a patient, I spend a lot more time talking either about that, if they have kids, and really educating them one-on-one as a doctor. As a public health person, again, I think there's a lot that remains to be done. And I think in America, probably a lot more than in some of the Asian countries. I know there's obviously the prevalence in Asia is so much bigger, so that justifies them being on the cutting edge of all of these efforts. There's some interesting studies that were done in, I think, in Taiwan, where they instituted a program, multi-year program, and of education awareness screening. They were able to lower significantly the prevalence as they looked at a cohort of thousands of children. Again, these are things that we should really start putting more effort and doing in a systematic way. I know China, for example, had recently some public policy that they wanted to limit gaming and video games for kids who now spend increasing amount of time playing on those devices because of progressive myopia, because they're seeing the epidemic firsthand. Again, we need to see whether those efforts are really productive and how to inflect the curve with all these policies, because some of them are not easy to institute or follow through. But again, as a physician, I'm trying to make an impact actually in my conversations with friends and family, because it's so common. You go to a cocktail party, there is somebody there who either has a kid or they have myopia, and people are genuinely interested now because they feel that there is more increasing awareness, especially in my Asian patients who come in already asking about compounded atropine or anything that they've heard out there that can impact their kids.
So they're already aware of these therapeutics. Just a quick one about education. As a parent, I think it's important for that message not to be all or nothing. So no screens at all, or, you know, a certain amount of time that children need to spend outdoors every day. I think the message should be, you know, it's not all or nothing. Some steps are better, and just keep building it up as you go. And I know, Andrzej, we have talked about different screens and how some screens are better than others. Could you tell me a little bit about that, the distance and the size of them?
Yeah, I mean, this is what I say to parents. I mean, I usually advocate at least, well, of course, it depends on the season and the availability of the sunlight, because this is the rule, but 2 hours per day outside. This is what I say, parents. It would be best to follow this rule. And then, of course, that with the young children, they should keep the screen as far as it's possible. I mean, saying that the TV is much safer than table, and the worst option is to watch a movie on mobile phone. This is horrible. So I certainly disrecommend overusing. Whenever I see that the child possesses a mobile phone younger than 7 years of age, I always draw the attention of a parent on that it should be very limited or even stopped. I do not see much sense for kids to keep these devices for unlimited use, because finally it's very difficult to control the use of these devices. So in short, I mean, we spoke about the risk factors, and I said that we learn about risk factors maybe not every year, but every few years. And one of the risk factors, which was quite recently raised and then confirmed in several studies, was a distance for near vision. And it was shown that the children, that when they read from a distance closer than 30 centimeters, that the progression is higher. So this is also the role of both parents, teachers, everybody. And now we know that even with the elder children, school children, we still can provide a good environment against the myopia development, like keeping the text in such a distance, at least 30 centimeters. This is what I say, parents. Yeah.
Let's move on to therapeutics. Sarah, and treatments in general, what does this landscape look like?
So we have a number of different types of treatments now. For a long time, orthokeratology or ortho-K lenses or night lenses or overnight lenses have been available, and particularly in Asia, they've been using Atropine for a long time. And what we've actually seen now in more recent years is that there's been clinical trials in children, in white children, European children, using Atropine and low-dose Atropine, and those studies are showing really good potential. We haven't and sort of non-Asian children, but the more sort of exciting area for me as a clinician feels like we have the development of the MiSight contact lens, so the ones with peripheral defocus, and also the two commercially available spectacle lenses, which have the defocus in the periphery as well. So those spectacle lenses are designed to induce peripheral defocus on the retina, and that's really where things seem to be moving in terms of the treatment aspect. So we know that whenever you put a spectacle lens or a minus spectacle lens on a child's or on an eye, you induce some hyperopic defocus. So we actually are inducing an area behind the retina that's slightly out of focus, and these new types of spectacle and contact lens are actually shifting that focus in front of the retina and almost turning off the signal for the eye to grow. That's the theory behind those treatments, and they've been really shown to have some really strong potential in actually reducing both the change in the refractive error of the eye, and also really importantly the slowing down the progression of the eye growth, so the change in axial length. And that's really what we're trying to slow down, because that's the thing that causes the issues that Sean was talking about in terms of those, because we're having a stretched eye globe, that we're having those significant eye conditions like what he discussed earlier with retinal detachments, glaucoma, etc. So those are the key sort of developments that we've been using, particularly the contact lenses and the spectacle lenses here in the UK. We don't have Atropine actually available to us in the compounded version yet, and it's only in clinical trial, but I can see that in the next few years, that's something that likely will be another option for us as well here in the UK.
Over to you, treatments.
Well, I can add that all of these approaches, I mean, pharmacology, atropine, and the optical approaches, they provide more or less similar effectiveness, between 50 to 60% of slowing myopia. So none of them is perfect in the terms that, well, we need to inform parents that we just slow the myopia development. We cannot stop it so far. So this is the first probably point. Well, I personally have been using well, because optical methods appeared quite recently. I mean, eyeglasses and contact lenses. Of course, orthokeratology was present for a quite long time. However, it was not very popular in some parts of the world, let me say in that way. So at least in Poland, in my practice, I have been using Atropine for a quite long time. I mean, and well, I have hundreds of children on Atropine, different concentrations. And the benefit of Atropine, it is that it's very well tolerated. I mean, the of course low concentration, the diluted Atropine, it is very well tolerated. Of course, we know that sometimes we need to increase the concentration to rise better, to get better effectiveness, and then, of course, we might deal with some side effects then. However, well, fortunately, in my practice, majority of children are all on low-dose Atropine. So this is what we can say to share our experiences, that the compliance is very good and the tolerance is also very good.
Sean, you have a wealth of experience with Atropine. Could you tell me about that and the data you've seen in clinical trials?
Right, I agree that none of the treatments, including Atropine, is something that can reverse or completely halt the progression. It reminds me that of the glaucoma paradigm. We're basically slowing down disease progression. We're not reversing or completely stopping. And it's a little bit unfortunate because regardless of what we do, whether it's a device-based treatment or whether it's a Atropine or some sort of pharmacologic, it's one more thing for our poor kids to be doing. It's already hard to get them to brush their teeth, make their beds, take care of their schoolwork. Now imagine we have to put them on something that actually will not be, in any form, shape that I can see, will not be a single treatment. Whatever it is, at least for the next few years, will be a chronic treatment paradigm, whether it's Ortho-K or some other glasses. Atropine is really fascinating because it's showing in different concentration, it does have a titratable effect on kids, and it slows down the progressive myopia. The 1% dose is obviously the most effective one. It shows the best effect in terms of slowing down the refractive error progression and also axial length progression. When you go to very low doses of 0.01, you're still seeing an effect, luckily and fortunately, with fewer side effects, but not as big and not as dramatic. So we're doing things a little bit in reverse with Atropine. You like to do drug development from a different perspective, where you start with the animal studies, with a rational hypothesis, and then you work your way. Here, we are actually starting from the clinic, from the epidemiology, from things we don't really understand exactly what the effect of Atropine is for sure, but we're now knowing that Atropine has an effect. We're now trying to do the dose finding, which is usually in reverse. You don't do the dose finding after you have the treatment. So I think there is a spectrum of dosing. We're trying to thread the needle on the dosing. Is it 0.01 or is it 0.1 or 1%? And there is a different trade-off, and the therapeutic index of the drug is different because of the side effects. And of course, kids are not very easy in terms of tolerating side effects. The part that I'm studying, and the part that really made me excited about one of the technologies that we have at Inovia, is the microdosing technology and the horizontal delivery. Because regardless of what drug we give, whatever therapeutic we give, we're putting it on the chassis of a century-old delivery technology, which is the eyedropper. And my patients that are glaucoma patients, very committed, have a hard time getting eye drops in. Imagine what's happening with kids when you ask them to put an eye drop. And we have some very encouraging data we presented that when you do horizontal delivery with our piezoprint technology, we have compliance and usability. 95% of the kids are doing it themselves, and they're not asking their parents to do it, which is really difficult with the eyedroppers. So I'm kind of trying personally, as what we do is to solve multiple problems, not only to have a therapy which we need in the US. I think you can get Atropine now through the compounding pathway, but it's very expensive. It's not covered by insurance, and patients are stuck with the cost, and you have a variable product. But at the same time, we need to show that we need to actually solve the delivery problem, because kids are going to have a hard time, much harder than anybody else, to actually deliver those drugs, even if they work. And again, efficacy of the 0.1 or 1% of 70-80% efficacy in slowing down the progression, maybe getting to the 40-50 early on, to me, that is still a win. Just like when we started out in macular degeneration, where PDT was not great, but it was a win because it led to the other therapies that became much better and not only slowed down the vision loss, but actually reversed the vision loss in macular degeneration. So I'm hoping the same will happen here. And atropine is just a bit of a dirty drug. It was not intended for that, but we can use it, hopefully, to bridge us to the paradigm when we'll develop better, more targeted drugs that will not have the same side effects and will give us even better efficacy. So it's a stepping stone, but the studies are very encouraging. And I'm always happy when I see replicate data, not just one study or two studies showing an effect, actually seeing multiple studies showing very reproducible effect. And again, from that, we'll just have to see. And the question of synergy is open for me, whether a kid can be helped synergistically by using glasses and the optical effects with a therapy down the road, because they do have mechanistically different approaches. And maybe we're able to extract a little bit more efficacy in the future if we can combine some of those modalities.
Jay, would you like to see Sean's invention in Europe, in Poland, or have you got any other innovations, new technologies to overcome the myopia problem on the horizon?
The question is for
yourself, yes.
For me, well, I am not very much aware. Of course, I heard about the approach or device, but of course, we welcome every let's say approach which will increase the compliance. The compliance is certainly an issue. I mean, so some similarities with glaucoma are obvious, and of course the pharmacological treatment of myopia is a long-term process. It's not for one. It's to some extent it's similar to glaucoma, because it is usually based on many years. So the compliance is a very important issue. Yeah, I agree. So I will be happy to see the results of the study, which is ongoing, obviously. And well, there is another advantage of atropine, and well, based on the recent modern studies, it is the oldest used approach in the myopia control. So we have now more or less 15 years experience after Atom 2 study with the low dose atropine worldwide. None of the optical methods can be compared with such a long term data, and the atropine is was used in myopia for a long time. You probably would not imagine how long. Do you have any idea when? Because I have studied it, by the way, so I can share the information from the history. When was the oldest study we were able to find to use atropine in myopia treatment? It was in 1860s. 1860s, the oldest study we're able, and we published that. So this is really the substance we know very well. I mean, in terms of the side effects and many other things. So, yeah.
Yeah, this is the time of resurrection. I think we're having old substances suddenly re-emerging because people are now using pilocarpine for presbyopia. So it's kind of interesting to see how we come 360 degrees and come back to rediscover certain compounds.
Yeah, I thought about the same. I thought also about the pilocarpine and the presbyopia. Yeah, you are right. Yeah.
And Sarah, have you seen anything else on the market or in development that is making you excited?
I suppose maybe not so much in terms of treatment, but one thing that does excite me is the fact that there are more commercially available ocular biometers. So something that is more commercially available for practitioners to actually measure eye length. And because that's, as I mentioned earlier, I think that's the key thing that we need to get our head around, is that's what we're trying to control, is that change in eye length. And if we're going to start implementing these different types of treatments, we need to have a way of actually monitoring whether they work or not. And there have been a few new devices on the market recently, and I think that's something that we really should be making sure that practitioners are aware of, and that, you know, instead of just monitoring what is happening with the spectacle correction, I think we really need to be looking at axial length as well, and making sure that whenever we're, you know, if we're selling these different treatments to parents, we need to be able to reassure them that, okay, yes, we're definitely making a difference in terms of, you know, where your child's eye is going, you know, because these treatments can be expensive, and we want to make sure that that we have adequate equipment to be able to reassure them that actually what they're paying for is making a difference. And some of the nice things that are included in some of those new machines are some, you know, almost like they're like a growth curve in terms of what your child looks like, in terms of what normal eye growth looks like, and you can then nicely track along where this patient is going. And I think that's one of the sort of, it's not maybe a new innovation, but it's just nice that it's actually becoming more available, because I know ophthalmologists have more access to biometers, but I know in optometry practices in the UK, it wouldn't be something necessarily that they would have access to. And I think that's where we need, the direction that we need to go if we're really going to be serious about treating myopia in children.
Are obviously a huge issue for the developing countries. And even if we might not have as much data about prevalence of myopia in those countries, that problem will keep growing over there. So, Sean, have you seen any cost-effective innovations, anything that caught your eye?
Again, I haven't seen anything that necessarily cost-effective. I think some of the public health programs from a purely public health perspective can be cost effective if they're combined with smart technology, because we can do so many things today, and we can monitor so many things through the smartphones that kids have, and there are even light meters in them, and so forth. So we could potentially institute some kind of public program that has that is very well baked with some sort of digital health smart technology, which can really be exponential and very thoughtfully implemented. Atropine may turn out to be a very cost-effective treatment in general, because again, it's widely available, and once it becomes approved, I think it will be cost-effective. We don't have to develop quite yet gene therapy or something that will really take a long time, and we already have quite a bit of evidence, as we see, tracking all the way back from 1860. So let's use it. It's just unfortunate you have to go through a pretty long development period, which all of these studies are about 3 years for endpoints. That tells you about 5-year trial conduction, which is quite burdensome. But I'm not aware. I'm sure something will come up as we leverage technology, because this is not, we have a better understanding today. Absolutely.
Yeah, and Andrzej, what will this field look like in 10 years' time, and 20 years' time, and even further down the line? What do you think?
Well, it depends how active we will be in our, let's say, future actions. So if we follow the example of some Asian countries, or we will be able to stop this process at some level. So I hope very much that we will be able to well, introduce some important as I mentioned, both, I mean, educational, preventive actions and the treatment options available for everybody. We are lucky in Poland, the atropine treatment is reimbursed, so it's quite inexpensive, I must say. Of course, we do not have ready on-label product, because it is not available in Europe. So it is off-label practice, and we are looking forward to have an on-label product available. However, regarding the cost, it is limited mostly by the number of compounded pharmacies more than the real cost, because it is reimbursed. So there are many barriers we need to overcome, but I'm optimistic. I mean, because, well, the number of people, experts in the field is increasing, and we can share experiences and knowledge in that.
Sarah, what do you think the future for myopia patients looks like? And is there anything on your wish list for a decade or two ahead for this field?
I think it's a really exciting time for us because of the different changes. I know there's definitely a wave of change in the UK. I think probably in the past 10 years, we've optometrists have really been there just to correct myopia. They've been just given spectacle lenses to correct it. I think now there's a real big transition that we need to move into. We can now provide some form of treatment, and that hasn't really come into place universally. And I think in the next 10 years, I think there will be a big change whenever the myopia treatments will be adopted across all of optometry. So I do see a real change happening in the next few years. In terms of a wish list, I think probably what we need to do in the UK, we have the NHS, so we have it's publicly funded healthcare. People expect to have their healthcare funded, and at the minute these are all private treatments. So I do think we've got a bit of a sort of socio-economic divide in who would be able to access the myopia care. So I think what needs to happen for us is really we need sort of a public health review of what should be offered in terms of, you know, once the evidence builds in terms of these have a really significant treatment effect. I think that needs to filter in to make it universally available to all children who need the treatment. So that would be my wish.
Sean, and what do you think the myopia field will look like in the States and globally in 10, 20 years' time?
I hope it looks very much like the glaucoma field. We have a lot of therapeutics, a lot of options, again, from devices to therapeutics, and so that we as clinicians can custom tailor to different groups. We would have better understanding of stratification of patients, because I don't think every myopic patient is the same. We kind of lump them, but there may be different subtypes and they may need different treatments. So I would really, and I think that it's going to happen now that industry and academia are really focusing on that, and there is one entry point into the field. We're probably going to have a lot more therapies, better therapies that will come in, because the population is there, the need is there, and I think we now have an idea of what is a therapeutic approach, at least a couple of them that can work, and we can refine them, which is, I think, what we're very good at.
Absolutely. More knowledge and hopefully effective treatments will come with that. And with that, I would like to thank you all for joining me today for this really interesting discussion, and for all your insights. It's been a pleasure talking to you, and I hope to speak to you again in the near future.
Thank you, Alexandra.
Thank you for having me.
Thank you all.